Hi, folks. Hello and welcome. Welcome to the July 13th, 2023 edition of the KubeStellar Community Meeting, broadcasting to you live today from Yorktown, New York. Today's meeting is jam-packed and full, so we'll get it underway. We have a host of folks on the call. If you wish not to be recorded visually, then please turn off your camera. Please remember to raise your hand if you're looking to ask a question or lead a discussion. Our contributor code of conduct that we follow is part of the CNCF. And in the interest of fostering an open and welcoming community, we pledge to respect all people who contribute through reporting issues, posting feature requests, updating documentation, submitting pull requests, or patches and other activities. We are committed to making participation in the CNCF community a harassment-free experience for everyone, regardless of level of experience, gender identity, and expression, sexual orientation, disability, personal appearance, body size, race, ethnicity, age, religion, or nationality. Basically just means please be nice to each other. Today's agenda, there's a few nomenclature changes that we have. There's a few issues that we want to go through. We have an introduction to something called KubeFlex that Paulo is going to lead us through, and I believe we'll have an update on decoupling of KCP with Ezra. If we have time, we'll get through the issues and PRs triage. If you have any items you'd like to add to the agenda, or if you'd like to add your name to the list of folks here, go to join us. Go and join us on KubeStellar-dev mailing list on Google Groups, and you'll get the meeting invites as well as access to this document so you can edit it. All right, let's start out first. So, Mike, do you want to walk us through the changes in nomenclature here that I've got listed? Or I can do it. It's up to you.
Sure. I mean, you can do it. You got it
All right.
written down.
Let's do it. Okay, so we've made some nomenclature changes in our documentation. Well, we're about to make some changes in the documentation, the code, the logs that are associated with that. The terms that have changed, there are 5 such terms that have changed. So if you're watching this and you're referencing any of these, please make note to change it in your documentation or your postings or other areas where you're referencing it. The term edge cluster will now be replaced with the term workload execution cluster. The term workload management workspace is now replaced by workload description space. The term inventory management workspace is now replaced by inventory space. The term edge service provider workspace is now replaced by KubeStellar core space. And the term mailbox workspace is replaced by the term mailbox space. The nice thing about simplifying workspace to space, as you see, is a common theme and thread in most of these, is that it lines up quite nicely with the work that we're doing with a few different space agencies and now and in the future. So
I think
KubeStellar
maybe,
is interstellar.
yeah, let me add a little bit more on the explanation motivation, right? There are 2 main changes we're shifting here in the terminology. One is the generalization from edge to more general multi-cluster. So we're not using we're not using edge versus center technology. We haven't exactly agreed on what to say instead of center or exactly how to say edge versus center, but at least these main terms, you don't see edge anymore. Not that edge is not important. We definitely include edge, but it's not exclusively edge. So that's the reason for that change. The other is the independence from KCP. So instead of workspace, which is a KCP specific term, we need another term. One strong candidate was logical cluster, but there are 2 problems with that. One is that it is already a specific term in KCP as well. It means a specific KCP thing, and we're trying to be more abstract, so it would be confusing to use a KCP term for something that's not necessarily the same KCP thing. And the other is the use of the word cluster, because what we're really talking about here is the behavior of an API server. It's a space in which API objects are held. In some sense, another kind of word that's been used for this is a higher level namespace. So when you use the word cluster, you bring in more connotations than just holding API objects. You bring in thoughts of like worker nodes and actually running workload, which is not what we're trying to say is necessarily part of one of these. And the other, of course, also is that this is a multi-cluster management system, and the word cluster appears there, and it would be confusing to have these higher level namespaces confused with the multiplicity of clusters that are being managed. They're very distinct things, and so having very distinct terms was one of the criteria that went into choosing these. That's all.
Okay, thanks, Mike. Appreciate that. Mike, you're up next. 772, propagation of single object status.
Yeah. So one of our actually maybe even more than one of our so we have some strong use cases that are special, right? Again, due to our origin for Edge, we definitely came out of the gate with a one-to-many model for the relationship between workload descriptions in the center and then copies actually running in the edge. Now just workload execution clusters, whether they be edge or something else. But the point is that this whole thing was designed under the assumption that there's a one-to-many relationship here between the description and then the running copies. But we actually do have some use cases that it's one-to-one. And in that case, the return problems associated with returning reported state gets much simpler. So we don't want to delete the general design for the one-to-many relationship. We want to retain the fact that we can cope with the multiplicity of working copies. But maybe it's worthwhile adding some additional consideration for the common special case of one working copy, because one of the big difficulties in all of this is that the workload description in the workload description space uses the standard Kubernetes object types, which have a spec and a status, for example, and this typically, and the status is designed under the assumption that there is one working copy. And we explicitly don't use that status in general because there's more than one working copy. But if there happens to be one working copy, why make the user's life hard? Let's go ahead and return the status into that status section in the workload description space. That's the suggestion here. And so far, that's all it is a suggestion. I guess so we're maybe some feedback on whether this is a good idea or not. I'm going to look into what it takes to add that to the workload projector in the placement translator. So that's what I have to say about that.
All right. June, I noticed you're on the call. Is there anything here that it would help with the work that you'll be doing with Argo CD?
Yeah, this is definitely one gap we want to fill because Argo CD today has the capability to retrieve the status of every single object that is delivered by Argo CD application. So we want at least do as good as them, and we also want to do even better than them in terms of we can summarize status across multiple clusters. So yeah, that's definitely one thing we want to do.
Okay. All right. Next up. Any other comments or questions for Mike? All right, Mike, I'm just getting back to the community agenda. Here you go. All right, next up, 771, Mike, hierarchy.
Sure. This has been something that's on our radar screen for a long time, but I think the point here is to try to move it along. So, this issue, we're just starting to think through the issues. So again, I shouldn't say again. So the way I see it, at least, there are, broadly speaking, two aspects of this. One is the center to edge or workload execution, whatever we're going to call it. The outward flow, and then there's the inward flow. For outward flow, hierarchy can help. Just technically, we all know that very high fan out gets to be difficult. So if you can break it up and do a few layers of not quite so high fan out, that just technically makes things easier. On the way back, it gets even more interesting because one of the central problems here is that the amount of reported state is potentially just too much to get back all the way to the center. And so there are different kinds of things that people want to do on the way back. I tried to enumerate them here. One is filtering objects coming back. So that is to say, selecting a subset of them. One is reducing the size of the object. So it's transforming a large object to a smaller representative or extract or abstract or whatever you want to call, however you want to say it, but a smaller object that carries the important part, the subset of the information that the center wants to get. Another more drastic kind of compression is combining several objects into one summary object. And then even more drastically or more dramatically in terms of reduction of what comes back is to not propagate back at all, but actually do the handling. So for example, if we've got objects that indicate some kind of an error status, put the error handling in the intermediate vertices in the hierarchy rather than do the error handling all the way at the root. Paolo.
Yeah, just a clarification. I think when we talk about objects, we mean Kubernetes API objects.
Yes.
Right? We're not trying to deal with generic application level kind of objects that are
exactly. That's
yeah.
right. We're talking specifically about the API objects that KubeStellar is manipulating. We're not talking about, say, cloud object storage. We're not talking about other things.
Okay.
Okay. All right. Any comments or questions for Mike on this? Actually, I have a question for Braulio. Braulio, you presented recently at the IEEE Edge conference, right? There was a paper that was presented there.
Yes.
Yeah, that was on something called Rendezvous, right?
Yes. So on the paper we are proposing a framework to do workload the deployments, collection of status, configuration update. Yeah, using a hierarchy where we introduce a rendezvous layer to help with the with scalability and the failure recover issues at the edge.
Okay. Great. So yeah, so that would be useful here too, right? Because it would allow you to use the rendezvous servers in that fan out that Mike's talking about, and to also do things like act on the return information instead of pushing it up as a status, right?
Yes. So I think yeah, we definitely we touched the idea of summarization of Fusion objects. At least we on the design. So the top of Fusion object. Like summarization, but Mike here introduced the issue of even doing some more extra computation, like reducing the size of the object return, so there are more interesting use case that Mike has raised on the issue that we can discuss and see if how our proposed architecture could solve others them.
Perfect. All right. Would you mind putting a reference to that talk in as a link into 771?
I'm not sure if the talk is already available online.
I thought I had a link to it already. Okay, when you get the link.
Okay, sure. Yeah.
Thank you.
Thank you.
All right. Any other questions for Mike? All right. Okay. So next up, we have a pretty cool treat. Paolo is going to talk to us a little bit about our sister repository, KubeFlex. He's been working on this diligently over the past couple weeks. Paolo, please take it away.
Thank you, Andy. So let me just share my screen. Okay, so as Andy mentioned, KubeFlex is now one of the repos under KubeStellar. So here is KubeFlex. Let me explain what it is. So as you probably know, we've been working to have now this more general architecture for KubeStellar, where we have different type of providers for logical cluster, or now we are calling them spaces. And so KubeFlex is one implementation that somehow provides some kind of more efficient way to just create spaces rather than creating full clusters. The idea is to create only the minimum that we need, still using standard upstream Kube API servers. So pretty much it's a way to create instances of Kube API servers plus maybe selected controllers in a way that is relatively efficient. It's probably not as efficient as creating KCP workspaces, but it somehow sits in the middle between creating full clusters and creating kind of KCP workspaces. And here is the project. And by the way, the generality, I think, is more general than just creating API servers, because once we start creating also controllers, the idea is we can create, it's a way to create somehow control planes where you can also have controllers and Kube APIs for specific use cases. So that's really one of the, I think, values of KubeFlex here. So this idea of creating Kube API servers, and maybe selected controllers and some CRDs, some APIs that are specific to certain use cases. Right now, we actually have implemented 3. And I'm going to go through that in the demo. The other point is the ability to select the type of storage backend. Normally in Kubernetes, as you know, you have etcd. Here, the idea is to provide more flexibility. For example, if you want to create a very lightweight kind of instance of space, you may not want to necessarily have to run also a dedicated etcd server for that, but you could use a shared etcd server with other spaces, so other API servers. And you could also select the type of storage. For example, you could use something like Postgres, and we support Postgres as kind of default for shared database. The other point is there is flexibility also in the choice of API server builds. So by default, we allow you to create upstream Kube API servers. For example, right now we're supporting 127.1. But you could use different type of API servers based also on the use case or what you need. And finally, the idea is to provide this single CLI that somehow simplifies the user experience in terms of somehow setting up the environment for KubeFlex and creating control planes, etc. Even if you potentially can do everything with standard Kube CLIs, but this somehow makes the experience a little easier. So let's talk a little bit about the architecture before going to a demo. So as you can see on the right side, we have hosting cluster. So this right now in KubeFlex is kind cluster, but it could be potentially any type of Kubernetes cluster, because we don't really have a particular dependency on a cluster, except something that we do at least for the development environment of KubeFlex, something that it's easy to use as a developer. So that basically for that we use kind, because that's widely used by developers. And so with that, we provide a way to somehow set up initially KubeFlex and everything in an easy way using the CLI. So in the architecture, we have a KubeFlex system namespace where we install an operator. The operator is watching these custom resources that are basically defining control plane instances. In the sense that, as I said, a control plane is essentially an API server plus controllers plus potentially some CRDs. And so the CLI, or even using kubectl, you can basically create an instance of a CR in the hosting cluster. These are cluster scoped, this CR. The operator will look at that CR, will watch the CRs. When one is created, is going to start looking at that CR and reconciling based also on the type of control plane, basically creating a namespace to host that control plane, create an instance of Kube API server. If it's shared database, it's going to connect that to the shared database. It can create an instance also of the subset of the Kube controller manager where there are selected controllers. For example, the garbage collector controller and other controllers that are somehow fundamental. But in general, it doesn't create all the things that you normally have in a Kube cluster control plane, for example, scheduler or other things like that, or many of the controllers that normally are associated with running pods, managing nodes, other things like that. Because we are really looking to create the most efficient, somehow implementation of this control plane, so spaces. So at this point, I will go to a quick demo to show the capabilities. I just want to mention that there are few releases already. We are release V021 now. So anybody that wants to try, if you're using macOS, it's pretty simple. If you have Brew, it's pretty much 2 commands. You basically create a tab. You basically add a tab to your Brew installation and just install KubeFlex. All it does is to essentially install the CLI. And once you have the CLI, I'm not gonna show the step because it takes a couple of minutes. All you need to have is a kind cluster. Actually, kind install, not even create a kind cluster, because KubeFlex will create the kind for you in a way that is already pre-configured with the ingress and everything that is needed to run KubeFlex, and plus installing KubeFlex operator as well. So if you run this command, essentially, it's going to create a kind cluster, and you end up with an environment that is ready to run, to create control planes now. Okay, so let's go to a demo. So I already have installed the latest KFlex, and we can take a look to the commands that we have. So you can create a control plane instance. That is the main thing that you pretty much can do here. Once you create an instance, typically what happens is that the KubeFlex CLI will switch the context of your current kubeconfig to point to the new hosted cluster, or the new, hosted control plane. So you can use this command ctx to switch back and forth between control planes, so going back to the original hosting cluster and so on, in an easy way. Of course, you could do that also with kubeconfig, set context, etc. But this makes somehow things a little bit easier. You can also delete a control plane, and the init command is mainly to initialize, as I mentioned, KubeFlex. That is to install KubeFlex on a cluster that you have. If you have kind, also we create kind, we set up ingress with all of those things. If you have another cluster, then this will pretty much install KubeFlex, but you still have to set up ingress and other things. And those are typically specific to the kind of Kubernetes you are running. Okay, so let's just try now to also check which version I have and if this is connected to a cluster. As you can see, I'm connected now to a cluster because I already installed KubeFlex. So I have a kind cluster when I'm running this, and the cluster is the hosting cluster is a 127.1 cluster running kind. Indeed, if I do kind to get the clusters, I should see that I have this cluster KubeFlex. So now let's go ahead and create a control plane. So all I have to do is to create control plane with a name, for example, CP1. And what happens here now is that, first of all, the KubeFlex CLI will somehow save the reference to the current context that I'm running. It's going to create, if we go back to this picture, it's going to create an instance of the control plane CR. And again, this is something I can do also using a standard kubectl command and the YAML for the control plane CR. But the CLI somehow make a little easier because after the control plane is created, is also checking, as you can see, is waiting for the API server to become ready. Once it's ready, also, it will retrieve the kubeconfig for that particular control plane that is stored within the namespace for that control plane. Is actually in a secret that contains the kubeconfig. It will retrieve it from the secret. It will set, it will merge somehow that in the existing context that you have, similar to what you have when you actually using kind. For example, if you are familiar with kind, you know that when you create a kind cluster, the kind CLI will automatically get the kubeconfig for the kind cluster, is going to set in your current kubeconfig, is going to also set the default context to that kubeconfig. If you create another kind cluster, it's going to do the same. It's going to get the kubeconfig, it's going to merge into the existing kubeconfig file, it's going to set the new context to the new cluster. And then you have to, basically, you can switch between contexts. So KubeFlex does something pretty much very similar. So whenever you create a new control plane, we retrieve the context. The kubeconfig is going to merging the existing kubeconfig file that you have is going to set the new context to the one of the new control planes. So right now, if I look at what I have here, let's check out. Actually, there is a command. I use another command just to see which one is my new context. I use this kube context, but you can also look at this using the standard kubectl commands. But you see that the context is now the CP1, that is the name of the control plane. And indeed, if I look at the namespaces, as you can see, I created previously this namespace my NS. Actually, I created this previously. I had this before from before. So let's actually look at this, right? I'm here now in this context, and now I want to go back to where I was in the hosting cluster. So if I go KubeFlex CTX, this is going to bring back the context to the original context. If I look at the namespaces here, as you can see, I have a namespace here, the CP1 system, where I'm running the cube, the CP1 pretty much control plane. We have the API server and everything. Indeed, if I look at what is inside that namespace, I can look at the pods, for example, minus CP1. I have actually two pods. One is the API server, and there is also the controller manager that is not running the full controller manager of the standard Kubernetes that you get in a Kubernetes cluster, because we don't need all the controllers if we're not creating pods or managing nodes or doing other things like that. We have a minimum set that is typically used in Kube API server for example, garbage collection or other things like that. So those are the few controllers that are running there. And as you can see, there are actually two containers in the Kube API server. One actually of them is a kind container, because I'm using a shared database. And we can take a look to the shared database if we look at the namespace KubeFlex system. There is a Postgres database that is a shared DB, as I have in my picture here. Right now I'm using the shared Postgres database. And so this particular control plane is using that shared database. And if I create another control plane using the shared database, it's going to also point to the same shared database. But as you can see, the other point is, in addition to the API server, the kind container, there is this controller manager, but there is no, for example, scheduler or Kube DNS, Core DNS, pods, or other things like that. So we really try to minimize as much as possible this control plane footprint. So let me actually go back now. And another feature I like to show, of course, I can create another control plane, right? Let's create another control plane just for demonstrating this. For example, creating a control plane CP2. And this pretty much will do the same thing, right? We'll apply a control plane CR, this time with a different name. It's going to create another namespace, as we see here. So basically, this is all done by this operator running in the back here in this KubeFlex system namespace. And once the API server, as you can see, takes a few seconds to get the API server up and running. And now I can check here. As you can see, these are different from the other that I had before, where this is my namespace I created previously. Now I don't have that. And pretty much I can interact now with this control plane the same way I normally interact with a Kube API server. And now I can switch back to CP1, for example. I can easily use this KFlex. Oh, sorry, not create. I just want to use a CTX CP1. So now in the other context, I can see, by the way, you can do the switching of the context the usual way, right? So now one other feature I'd like to show is that so far what we have created are sort of standard Kube API servers. But part of the power of also KubeFlex is to be able to create different type of control planes. And by the way, if I switch now back to my hosting cluster, I can see that I have, if I list these control planes, you see that I have these two control planes. These are CRs. And you see there is a type K8S. So this is sort of the default is creating pretty much, as I mentioned, a Kube API server plus controller manager and stuff like that. So let's say now that I want to create a different type of control plane that allow me as a developer in this hosting cluster to, for example, create pods. And there is a project in community called vCluster that does pretty much that. And we have also integrated with that. So we can use pretty much the same plumbing, the same infrastructure. Actually, I'm going to do that now to create different type of control planes like that one. So if I do create, for example, a CP3 now, and I say type is vCluster, I will show that this is a slightly different type of control plane that there is a little more, in terms of footprint, because he has also a DNS, core DNS server. He has a little bit more things. He has also a kind of a syncer. This is all part of the vCluster kind of control plane. But I can do some other thing that is, I think, quite interesting here, right? So I'm here now in this new control plane that is of type vCluster. You can see that now I have by default these namespaces. But the cool thing about this is that I can do like I can do something like run a pod, for example. Let's see if I can do that. Nginx. And the pod will run in the hosting cluster. So let's say image Nginx latest. Okay, so this created a pod. And by the way, I cannot do that into the other type of control planes that I had, like the K8s, simply because I don't have their controllers to run pods or stuff like that. In this case, what happens in the vCluster, and I invite you to look at vCluster if you're interested, is that there is a syncer that essentially synchronizes the pod to the hosting cluster. The pod actually runs in the namespace of in the hosting namespace in the hosted cluster. So let's take a look to this pod I just created. You see the pod is running, right? This reminds, some people may remind a lot the feature in KCP of using a syncer, having a backend cluster to do this. The cool thing about this is that now I can also do things like exec into that pod. For example, exec -it Nginx, and let's see if I run something like a shell. Sorry, it's -it. Okay, so the name is actually pod Nginx. One sec. I think I have Nginx. Let's see if I have done something wrong. Let me try something else. Okay, Nginx. Yes, so I can take logs from Nginx, and I should be able to do exec. I'm not sure why. Exec -it. Probably I misspelled something. Okay, so maybe it's something that I'm doing wrong. But anyway, the point is, in general, this part of the way vCluster works is that you can also interact with these pods. You can do like exec, you can do logs, you can do the usual stuff that you do. And if I, just for showing what happens when I go back to the hosting cluster, where is this pod, right? Someone may ask, where is it, right? If I look at the pods in the namespace CP3, you see that there is this, first of all, there is the vCluster. This is really the API server plus syncer plus some other stuff that vCluster has. And there is a core DNS. So this is a little bit more heavyweight than just running the pure API server, the way I'm doing now. But there is also this pod. This is the one actually created from the inside the vCluster, right? And now, of course, what is the use for this, right? It's mainly to give developers a way to create pods and to basically have their own kind of cluster and run stuff in this hosting cluster. But the main reason I'm showing this is to show us actually the flexibility. That's why it's called KubeFlex. So KubeFlex, in terms of creating different type of control planes, it possibly integrates with other projects. One last thing I want to show before finishing is that using the same pretty much approach I just used to create this vCluster, I want to create a different type of control plane now that is OCM control plane. So OCM is Open Cluster Management. There is also a set of APIs for that that may be also interesting for us in terms of possibly building some kind of integration with that, maybe some front end using some of those backend APIs, for example, for inventory or registration of clusters. This works pretty much the same way, and is using also a lightweight version of OCM that is part of their project that is called the multi-cluster Open Cluster Management Control Plane. So it works pretty much the same way. The only difference is that I'm providing a different, basically, type of API server. Now it's ready, and if I look at this, again, I can list the namespaces, but the interesting thing is that I can look at CRDs, and you see I have all the CRDs, in this case, of Open Cluster Management. And I'm not going to go through that now because of time, but I could actually use that to register, for example, a kind cluster and show that in my inventory and other stuff like that. That could be maybe for another demo. But anyway, at this point, I just wanted to show the basics of KubeFlex. And of course, other possible extensions here is the ability to create control planes that support certain type of APIs. So, for example, I want to provide a control plane to manage cross-plane kind of APIs, for example, or maybe Knative kind of APIs, etc. The idea is really to sort of run the controllers needed by those APIs and provide somehow the ability to run this in your control plane. Another point maybe for future that we've been discussing also with June. June has been looking at KubeBind. Is can we sort of run something like KubeBind in this environment in KubeFlex? So the idea is that in KubeFlex I could have providers. I could have maybe some of these control planes could be providers of APIs where they run the controllers. For example, imagine a cross-plane provider, and some of these control planes or spaces will be consumers. So if we manage somehow to put that together, then the idea is I could create a control plane, maybe a K8s control plane, import APIs from a provider, and then start pretty much consuming those APIs, all in one kind of environment. I see that. Okay, so that's pretty much all I have to show. Let me unshare. I'm going to open the floor for any question or clarification. Again, for those that would like to try, it's pretty easy, right? So as I show, if you have a Mac, it's especially easy. It's pretty much brew commands, couple of commands, you get pretty much everything set up and running.
Okay, any questions for Paolo? All right, Paolo, what we can do is we can dice this up and post this as an explainer on our TV station. I think this would be good for people to see.
Thank you.
No questions? Okay, folks. Great. Thank you, Paolo.
You're welcome.
All right. I don't see Ezra on the call, so we're not going to go through decoupling of KCP. We're at 41. Does anybody have a desire? I think Franco's on the call. Mike's on the call. Do we want to whack away at 778?
You mean 788?
Oh, yeah, that's what I meant. 788.
All right. Yeah. Maybe we'll just touch on it.
Yep, go for it.
So, what we've currently been practicing is a very simple use pattern or use case embodied in the quick start, where the KCP server and KubeStellar controllers are run as processes in some host, and the workload execution clusters or kind clusters on the same host, and there's IP connectivity from the workload execution clusters where the syncers run to the KCP server that holds the spaces or workspaces in particular. But we want to graduate to more articulated scenarios, such as packaging the KCP server and KubeStellar controllers inside a container, and having some more network distance between these things. So in general, we need a more sophisticated paths from the sinker to the KCP server, and that issue is written specifically for the sinkers. But of course, there are other clients that are interested as well. In bigger pictures, there are clients, of course, that, for example, want to manipulate stuff in the workload description space. So to support these more general scenarios, issues come up. The address that the KCP server, currently, our typical practice is to not tell it anything, maybe pass a bind address, but in general, the KCP server is not running in a place where it actually can use the IP address that these other clients will need to use. In general, there are proxies in between is the issue, really. Well, there's proxies and IP stuff. So I'm not sure I want to talk through it now. Maybe I will just very briefly, right? So one of the primary issues is proxies. This includes load balancers and other kind of proxies. And for any proxy, you have to decide whether the proxy is going to terminate the TLS connections from the client and thus open its own connection or not, in which case it has to do TLS pass-through. If it terminates the connection and opens a fresh connection, it has to impersonate the client and be authorized to impersonate the client. That's not impossible, but it's kind of a high bar to arrange and believe that you've got properly secured. The TLS pass-through is a little more common. In any case, you still have to get out to the client. The kube client config, the kube config the client uses, is going to tell the client what to open the TCP connection to. That has to validate. It gives the server certificate that comes back. So there's the issue of getting the right certificate created and used by whatever terminates the TLS connection. When you're doing pass-through, if the proxy always passes through to the same thing, then it's relatively easy. If you're dealing with a load balancer or other proxy that can steer amongst multiple backends, then you have to think about how that steering is directed. There are different technologies out there that have different answers. The simplest answer is just looking at the host name in the authority part of the URL. More generally, these things can look at the URL path as well. And in any case, when doing TLS pass-through, the HTTP requests are not evident to the thing doing the steering, because that's all inside the encrypted payload. There is in TLS the server name indication. So the question is how to get that right. If I recall correctly, that defaults to being the host name that the client opens the connection to, and in general can be controlled, although I don't recall at the moment whether there's a way in the kube config to set it apart from, of course, controlling the host name in the server. So there are various control knobs available on the command line of the KCP server. They're inherited from the Kube API server, except an important and relevant and a very helpful one called --bind address has been disabled in KCP. I don't entirely follow why. I'm pursuing that with the KCP team. But perhaps the most powerful option is to give the certificate, give the server certificate to the server rather than let it generate it. That lets the high-level code take a lot of and exercise a lot of control that's relevant here. Many things that install and run Kubernetes follow this pattern. You'll find it for example, in Kubernetes in the hack/local up cluster script. I believe you'll find it in Kind. You'll find it in kubeadm, which Kind uses. You'll find it in a lot of places. So we shouldn't be shy about doing that. And in fact, I think we should look to those places for inspiration and understanding and clues about the the options that need to be provided when offering that, and the ways of supporting it. I think I'll stop there.
Okay.
Yeah, I've just one comment I just added to the issue. There is some work in community for similar use case. It's pretty much the same problem that you are discussing, where a list of options is presented and tested in a way. And pretty much this goes through all the way you could connect a Kube API server running into a hosted cluster to the outside. So for example, they talk about node port, ingress with pass-through, ingress without pass-through, and all these other options. I think that will be beneficial to take a look to that doc.
Thank you.
Excellent. Franco, is there anything you want to add to this discussion? Okay.
Sorry, I was muted. I think one interesting option for KCP that is listed in the issue is, for me, the external host name, and obviously looking into the TLS arguments. What I'm not clear is when you use the external host name as an argument and you specify URL there, the certificates that KCP is creating by itself are not matched to that URL, and that URL is embedded in a kubeconfig, so it doesn't quite make sense to me why that would be the case. That's at least my experience.
I'll follow up with you offline on that.
Okay. All right. I wanted one particular, we don't have a lot of time to do triage, but I wanted to go through the PR list here real quick. I see we don't really have anything we can comment on here. I don't see anybody on the call from there or there, but there was the Docker container. Franco, could you give us an update as to where you are on this particular PR? 764.
The PR was created for a specific use case in mind, which was to enable a user to easily play with Docker on a host OS instead of installing KubeStellar through the Bootstrap. You would just download a container image and run the container Docker image. So there is a makefile script that is helpful for that application. And so far it seems to be working in the sense that you can spin up KubeStellar in a container or on your local machine in a Docker container, and you can interact with it from the host. That is done using the IP of the container at the moment. So this is an enhancement of this PR would be once we solve the 788, to make this more generally available so that the container can be accessed from something else that is not the host OS at the moment.
So based on your comments here, is this okay to go ahead with and then augment later, enhance later after 788 is completed? Can this one be reviewed?
I think so. I mean, Ron and Kat has been using it. I didn't see any specific comment. There are some comments that I would like to implement from Mike, perhaps. So I can try to go through them this week. I was focusing on the ingress issue and trying to solve that as a user functionality focus, but I can go through some of the comments that Mike made, and I think I should be able to implement most of them.
Okay, Mike?
Yeah, I'm not sure I would look to 78, expect 788 to be completed anytime soon. I think it's a kind of a ball of wax or a campaign, an issue to maybe develop solutions for over time. I don't think there's one use case or pattern necessarily to rule them all.
I was hoping that was the case. I was just making sure it was explicitly clear.
So let me put it this way. So let me go through my comment, which I read through quickly. I think they're all reasonable. So let me make those changes. Then we can have this Dockerization in place, perhaps, and then we can work on the Helm charts, and we can work on the 78 enhancement. You know, no matter what, we need a container, right? So we can change the entry and stuff like that in the future, but at the moment, this seems to be working.
Okay, yeah, I was hoping that was untangled. Okay, good. Yeah, let's proceed. Great. Okay, folks, listen, we only have 7 minutes left. I'll take any comments or questions from the community here. I don't think it's a good time to start a triage. Okay. All right, folks, anything, if there's no other comments, questions, or information from the community, I'll go ahead and end this specific call. I'll post the meeting as a standalone entry on our TV station on YouTube, but I'll also cut out the part and have it stand on its own for KubeFlex. So as to get some more people to have some interest and take a look at that. Okay, folks, thanks so much for your time today.
Can I ask a question, perhaps?
Yeah, Franco, didn't see your hand. Go ahead.
So there was a new release, 0.4.
0.4.0. Yeah.
Perhaps can you highlight the changes or what's new or what is interesting for a new user to use 0.4 instead of the previous one?
I think this particular release incorporates the specifically released so that we could get past the issue that we were having a chicken and egg for the prep for Syncer. And so it was just reestablishing or rebasing the CI/CD from my point of view. Any other major changes, I don't really know, other than documentation changes that will become part of the most recent stable branch at this point.
Okay, thank you.
Mm-hmm. Okay. Any other questions? All right, thanks, folks. Have a great day. See you in 2 weeks.